All right. Today in Algebra 2, we have 3.2, day 3. Okay, so we're wrapping up 3.2, the solving algebraically. So today we're just putting the two things together, substitution and elimination. So you're going to get a choice when you're solving which way you want to solve it. Okay, so I've put both of our directions for solving by substitution, solving by elimination in there. And we're just going to dive right in. Like we've already been doing substitution, we've already been doing elimination. You just get to choose how to solve them today. All right, so example 5. Let me erase this. Okay, solve the system algebraically and classify it. Okay, so we have 8x minus 4y equals 1, 2x minus y equals negative 3. Okay, we do have a variable by itself, so we could solve for y and use substitution. Or you could multiply these and get the additive inverse and go from there. Does not matter. Okay, so, and I might show, actually on this first one, I'll show you both methods. And again, it's totally up to you which one you want to do when you want to do it. So let's do substitution first. So I'm going to subtract 2x from both sides here. So I'll have negative y equals negative 2x minus 3. Divide by negative 1. And I will have y equals 2x plus 3. All right, so when I do substitution, remember I'm going to take this value, this expression, and plug it back into the other equation. I can't use the one that I used first. So I'm going to take this 8x minus 4, but my y, right, I'm going to put my y in there. Y is 2, the quantity 2x plus 3. And then I'm going to go back, 8x minus 4y equals 1. Okay, I'm going to need to distribute. So I have 8x minus negative 4 times 2 is negative 8x. Oh, sorry, I thought I had green earlier. Apparently I had black. Negative 4 times 3 is minus 12 equals 1. I can combine like terms. 8x minus 8x equals 0. Right? Like what? So now I have negative 12 equals 1. Yikes. What just happened there? Seriously, what just happened there? Good. Hopefully you remember that from yesterday. This has no solution, so it's inconsistent. Okay, so we have no solution. Or remember, you can put the 0 with a line through it, which would make this system inconsistent. Now, that's if I solved it using substitution. If I did elimination, okay, so I have 8x minus 4y equals 1, 2x minus y equals negative 3. Okay, so I could, let's see, I have a 8x and a 2x. What would I multiply 2x by to get a negative 8x? All right, negative 4. Perfect. Okay, so let's look at that. So I'm going to take 8x minus 4y equals 1. I just rewrote my first equation. And my new one on my second, negative 4 times 2 is negative 8x. Negative 4 times y is a positive 4y. Negative 4 times negative 3 is a positive 12. Okay, so now 8x minus 8x, well, those I eliminated. Negative 4y plus 4y, those I eliminated. So I have 0 on the left. 1 plus 12 is 13. Again, not a true statement. 0 equals 13 is not true. I have no solution here. Okay. So this one's just kind of getting you in the habit of like, okay, it's okay to have no solution. You might go back and check your work, but you did it right. You got no solution. Okay, but again, you can solve it with substitution. And maybe I should put that here. We did substitution, and over here was elimination. Elim, okay? You can solve it either way. You get to choose. Most of the time. There will be a time on the test where you'll have to do at least one using substitution and at least one using elimination to show me you know how to use them. I did not leave much room on this example 6 down here. My goodness, what was I thinking? Okay, so let's solve the system algebraically and classify it. So I'm probably only going to use, well, I will only use one. If I look here, right, do I have any variables that have a coefficient of 1? No, I don't, right? I don't have an x by itself or a y by itself. So substitution is not going to be ideal. This is one that I really should use elimination on. Now, I'm not saying you can't use substitution, because you can. You could divide, do all the work and divide by 2 and get x, and you're going to have a fraction. But then you're working with fractions, and it makes it harder and just more cumbersome. You can do it. Don't let me keep you away from that. You can do it. It's just more challenging. Okay. With that said, let's look at this. Top equation, 2x plus 3y equals 4. These variables are smaller. So let's start with the x. What can we multiply 2x by to get negative 10? We want the opposite of 10. Perfect, negative 5. So this is going to give us negative 10x. Negative 5 times 3 is going to give us negative 15y. Negative 5 times 4 is going to give me negative 20. All right, then I still have the equation I didn't do anything with, positive 10x plus 15y equals 20. So we're going to add those together. Negative 10x and 10x cancel. We eliminated them. Woohoo! Negative 15y and a positive 15y. Oh, geez. They cancel, right? We eliminated those. So now we're left with 0 on this side. Negative 20 plus 20. Wait, negative 20 plus 20. Well, that's 0. But this time, this equation is true. 0 equals 0. This is true. Absolutely 100% true. So when that is the case, when 0 equals 0, this one is called a dependent consistent. Okay, do you remember how we write our solution for that one? All right, the solution here, when we have dependent consistent, yes, is using set notation. So it's the ordered pair xy such that, and we use our equation. But wait, our equation, where's our equation? It's supposed to be in slope-intercept form. We don't have that. So we need to do a little bit of work over here. So we're going to take this 2x plus 3y equals 4. And we're going to put it in slope-intercept form. So we're going to subtract 2x. We have 3y equals negative 2x plus 4. Divide by 3 on both sides of the equals. Y equals negative 2/3 x plus 4/3. Okay, so that's our equation. And so that's what has to go here. So we have our solution is the ordered pair xy such that y equals negative 2/3 x plus 4/3. Okay. Now, if you would take the other equation, 10x plus 15y equals 20, and you put it in slope-intercept form, what equation would you have? The exact same equation, right? Like that's dependent consistent, is that they're the same line. Also, go back here to your solution and finish out that set notation. I forgot that brace. So squeeze it in there for your set notation. Awesome. So not only are we solving using substitution or elimination, but we're getting some practice with different types of systems, not just the independent consistent. All right, one more on the back where you have plenty of room. Example here is 4x equals 8y plus 8 and 6y equals 3x minus 6. Okay, so we don't have any that have a variable by itself, so substitution doesn't really seem ideal. Our variables don't really line up, right? 4x, 8y is over here, 6y, 3x. We need to do some manipulation on both of these. So let's take the 4x equals 8y plus 8, and let's get our x and y on the same side. So we're going to have 4x minus 8y equals 8. Let's do the same thing with our other one. We have 6y equals 3x minus 6. Okay, let's get x and y on the same side. So subtract 3x. Okay, we have our x's coming first here, so let's do the same thing here. So we're going to have negative 3x plus 6y equals negative 6. All right, now we have them in kind of the same format, right? More that standard form, the x and the y's. Okay, so now that we have these, let's compare. We have 4x minus 8y equals 8, and negative 3x plus 6y equals negative 6. Well, man, neither of these are factors of the other one, right? Like, I can't multiply 3 to get 4. I can't multiply 6 to get 8. So in this case, I have to multiply both equations to get a common multiple. So if I'm looking at these, I'm going to go in on the x's. Okay, I'm going to focus on the x's because the numbers are smaller. 4 and 3 have a common multiple of 12. So I'm going to take this one, 4x, and I'm going to multiply it by 3. So I'm going to end up with 12x. Okay, so this is going to be 3 times 4 is 12x. 3 times negative 8 is negative 24y. And 3 times 8 is 24. On the next one, okay, I'm going to multiply by 4 because I want a negative 12, so my 12s would cancel. Okay, so 4 times negative 3x is negative 12x. 4 times positive 6y is positive 24y. And 4 times negative 6 is negative 24. You're probably already seeing some things like, oh my gosh, again. So 12x and negative 12x cancel. Negative 24y and positive 24y cancel. So we're left with 0 on the left of the equal sign. 24 minus 24 equals 0. Okay. So here it's a true statement, which means this is, what did we say this was? Dependent consistent, right? This is dependent consistent. All right, and so our solution is that set notation for the ordered pair xy such that y equals. And there we have it again. We don't have y equals. We don't have it in slope-intercept form. So we need to take one of the equations. I'm going to take this one because the y, this is going to be the easiest because the y is already there. Okay, so I'm going to take the 6y equals 3x minus, what? Not 3 divided by x. Equals 3x minus 6. Divide by 6. So then I have y equals 3 divided by 6 is going to reduce to 1/2. I cannot write, my goodness, 1/2 x. Negative 6 divided by 6 is negative 1. Okay, so we have to put that over there. So our solution then is the ordered pair xy such that y equals 1/2 x minus 1. And close your brace for your set notation. And there's your equation for that one. Okay, not all the ones that I give you are going to have you making the choice, like when you get to make the choice. Not all of them are going to end up this way. Most of the problems are going to be independent consistent. But I also want you to be familiar with inconsistent and dependent consistent, okay, and how those are going to show up, because you need to know all of them. But most of the problems are going to be independent consistent systems. All right, have a great one.